Welcome to the last session of ArcGIS in this series of lectures on spatial statistics and spatial econometrics. In this session, we are going to look at raster data, how to visualize such raster data, how to look at its property, what to be careful about, what can we do to manipulate these data, and then finally our quest of taking this stuff to an Excel sheet, to a statistical software, and maybe on R, and analyzing this data from there. After this session, you will go into learning hands-on exercises on R. So it's kind of a natural progression. Different sophisticated techniques like building a variogram model, estimating a variogram model, spatial regressions, they will all be taught on R because there are very nice routines, packages which can be used. ArcGIS, on the other hand, is a very nice visualizer, manipulator, data management tool, right? All of those things can be done here as well, by the way. You could estimate a variogram model in ArcGIS, but R happens to be much more powerful, natural, software where you can do many other things. So what we are really doing here is we are trying to learn how to visualize, really get a hands-on feeling of these data to sort of, zoom in and look at what's happening and do some cross-validation and things like that on ArcGIS. While mostly analysis, so data management manipulation maybe happens here. You want to create pictures, visual maps for your, research, for your papers, articles. You could do it all on here. But when it comes to analysis, perhaps it's best to take the data to a statistical software. So that's the journey that we are completing here, right? So in that spirit, let's go on to look at the raster data. So an example of raster data, as we have looked in your classroom, is the Bhuvan ISRO data. So how do we get there? If we simply Google Bhuvan land use, land cover data, something that's out there. So the first thing that comes out is these data. So we have seen these data, like you can select whatever theme you want, and then there are these statistics you can look at. There is an entire 15 to 20 minute module in your lecture series dedicated to these, to the Bhuvan portal. But ultimately, you want to get these data, you can download these data, there is a form you have to fill and all that. So, like here, I'm just showing one type of land use product, under web services, you can figure out how to sort of take these data bring these data to your computer. I've done that for you here, but you will have to then, download these data to be able to work with them, right? Okay. So, so say we have downloaded this data for an area of interest of our choice, right? So I'm going to show you such a data set which I acquired from ISRO. So in my folder, again, these data are to be found here. So I have LULC, land use, land cover, 250K, that's the map, scale, 2005-6. And then it's a TIF file. So instead of shape, now I have TIF files. I also have such a data for 14-15, 2014-15, and I have some other files, right? So I'm going to drag this to my map and see if I get something. It seems like it doesn't get dragged. Oh well, it does. Fantastic. It got dragged. Okay, so here now I have this data for a separately requested from the Bhuvan portal and acquired from there, which doesn't exactly look like the UP data. It is a data set that is, looks like more like Indo-Gangetic plains. This is the Gangetic plains. Here is the river, and these are the Gangetic plains, right? So first thing that I could do is I would say, okay, I am only interested in analyzing UP data. So I'm going to now clip the data according to that. So I'm going to go to my geoprocessing and I'm going to say clip raster. I've just, I've just opened it for your, so I've just searched clip raster. It says it's there in data management tools. I'm going to say open. Input raster, there is only one raster on the window. on the left, right? By the way, one thing that we should always do is we should always look at the properties of our data. So the data are, I should look at the spatial extent, spatial reference. Well, it is WGS 1984. That's fantastic. So I can actually overlay the vector files on it, and the locations I see are a good representation of where certain types of land use types are. The data can also be seen here. I mean, this is in the physical folder, right? In the other folder, you only see one file, LULC, 0506 TIFF. You only see this file, and you see this file. Just like shape files, these data also come as packets. So they'll have projections, they'll have attributes. So they are not just a single file, they are multiple files. So if you want to copy paste these data, move these data around, it is not a good idea to do them from physical folders. Rather, we should go back to our catalog, and we should say, I want to copy these data and I want to take it to a different location, let's say here, and I'm going to say I want to paste these data. Okay, sorry about that. So I want to copy these data. I want to go to this folder. Let's say I go to folder right here, India admin data, and I say I want to paste these data. So that's done. So I have this data now in India admin as well. Let me go to the physical folder and figure out whether that happened. So I'm going to say India admin data, and I'm going to look for, here we go. So LULC 250K, I hope you can see LULC 250K has total, I think, 1, 2, 3, 4, 5, 6 files that came with it. They all moved together when I moved them as a single file from our catalog, right? So again, that's the best practice, and you should always follow this. And okay, so I have been able to open these data, but what are these different colors, right? So I can, on these data, if you see, I have an arrow which I click, and I have different colors that represent different classes, right? I have class 0, which is a black color, class 1, which is a red color. If I pay attention, here is the NCR region. Seems like 1 represents urban or built up areas. Then there is 2, 3, 4, 5, 6 all the way to 18, 19 till all the way down. There is a singular color, and I don't see those things. So I guess there are no classes here. How do I know what these classes are? Well, when I download these data, I request these data from ISRO. They also provide me with a lot of metadata, right? As part of those metadata are these, first of all, there is this README file. The README file has the license. How do you cite these data? What are the purposes you can use these data for, and so on and so forth, right? Okay, so that's one. Second is the LULC classes. Well, 1 is built up, that's what we guessed. 2 is Kharif crop, 3 is Rabi crop, Zayed crop, and 5 is double and triple crop. Okay, so let's pay attention to the first 5. So built up, Kharif, Rabi, Zayed, and double triple. Okay, so let me go back. The first is called, okay, can I rename this class? Okay, let's see if I can rename 1 to, okay, let's see, display, source, metadata, general. No, I thought I could just, anyway, so I know that 1 is built up. I can write on a piece of paper if I'm not able to edit here. I think one can edit these things, so you should look up at your own time how to edit these classes. So 1 should be called as built up. 2 is Kharif, which is yellow. Where do I see this yellow on my map? Well, I see a lot of it here, right? Where's this place? Well, let's look at the districts and let's see what this district is. Okay, I'm going to open the districts file. I'm going to label the districts. And I know that Bijnor has a lot of Kharif cropping going on. Okay, a lot of Kharif cropping going on in Bijnor. Just trying to bring these things up here. Okay, a lot of kharif cropping going on in Bijnor. Rabi, that is the winter cropping, non-monsoon, sown around late November, early December, and then harvested around March, early March, mid-March, right? That's Rabi, right? So now a lot of Rabi south of the river, right? So here is Ganges, south of the river. You have a lot of Rabi going on, right? Look at Jalaun, Jhansi, Hamirpur. A lot of Rabi cropping in 2005-06. Zayed is the summer crop, right? It happens in the months of April, May, June, right? So that's it. So March, April, May, June. Where is Zayed? Let's try to find out. Can I find one single pixel of Zayed? Okay. All right. Not quite, right? I mean, there is not much of a Zayed going on. Well, there is some here, it seems. No, that's not Zayed. So we need a brown color. If I have Zayed, it's going to be brown color. So we could probably look at the east. Oh, there we go. Yeah, there's some Zayed in Bihar, it seems, right? This is all. So look at the water bodies nearby. So you know where the summer crop is getting its sustenance, right? Okay, that's how we do visual analysis. Then 5 is double and triple. So this is this green. There's quite a bit of this green, by the way. So there are this double triple cropping means the land is being cropped 3 times in a year, at least twice or 3 times. All 3 seasons are cropped. That's interesting, right? So there are a lot of double triple cropping in Uttar Pradesh, which makes sense. I mean, these are good soils, very rich in natural resources, and so on and so forth. Okay, so I have these data, and here are the colors. This is also downloaded from Bhuvan. I've taken this from Bhuvan. So and you can tell what is what here. Okay. So you can compare this file with this file here, and you can name your classes. Okay. Now I want to work with only UP data, so I'm going to clip the raster. I'm going to go back to my geoprocessing. I'm going to clip raster. Okay, I'm going to find clip raster. Okay, input raster is only 1. Output extent, I want to work with UP data, so I'm going to say UP state from the DEVA GIS. It automatically fills the extent, and it says clip. So I'm going to now take my raster data to the raster data folder. I'm going to say LULC 0506, and I'm going to say UP clipped. Okay, and I'm going to make it a TIF file. I could also use .img, by the way. IMG is as good a extension for the raster data. Okay, save, and no data is 0. So no data means 0, right? So I'm going to say that's okay. Maintain clipping extent. Well, that's interesting. What does it really mean? Well, it really means is that if it is checked, the number of columns and rows will be adjusted on the pixel that will be resampled exactly to match the clipping extent. What does that mean? Okay, let's first see what it means. Okay, if you go to the boundary of Uttar Pradesh, right? I'm just going to go to symbology and make it a slightly thinner boundary. Okay, what happens is that at the boundary, here you see, different pixels, right? And if I pay attention to a particular pixel, the boundary is crossing through the pixel. And the question that this checking and unchecking is about is that whether I want to count the pixel inside the boundary, right, that is overlapping slightly outside the boundary, or should I be strict and say no, if you are anywhere outside the boundary, I am not going to include it in my clip. So I'm going to leave it unchecked. I'm going to be a bit liberal about it. I'm going to be okay, that's fine, just because the pixel is always a square and the administrative boundary is crossing through some of these pixels, I don't want to throw them out. I want to take them in. Okay, that's a decision as part of an analyst. You may decide to throw them out. You should try anyway. Okay, so I'm going to say run. It's going to run it 100%, done. Right? It says building pyramids, clip raster is completed. Perfect. Okay, so if I uncheck, I am going to have a clipped raster. Okay, so the clipping now has happened according to the rectangular extent. Okay, it didn't exactly happen according to the state. Okay, let me now redo this with the maintain clipping extent command and say clipped 2 and we'll say run. Okay, it's running, it's working right here. Very good. Okay, it's done. Okay, still I have the same thing, but now the pixels that are going to be counted are going to be a bit, different. Okay. All right. So I have now a smaller set of data, right, which is not as large, which is approximately according to the boundary of the UP file, right. Next step that I might want to do, just like for groundwater data and railroads data, is that I might want to, figure out the land use profile inside the districts. Okay, so let me just change the color of this thing because, it's harder to view that color now. Okay, so I might want to know which district has what percentage of which data type, which land use type. Okay, for that we have this tool under geoprocessing. We have this tool called tabulate area. So the tool, it says, is not licensed, so we have to license the tool. Okay, so let's figure out a way to do that. Okay, so now that we have our clipped file for Uttar Pradesh, it's a separate file that we have created. What we can do is we can now navigate through different districts by name, which I know by name. For example, Hardoi, I can visualize the land use makeup in Hardoi in 2005 and 6, right? I can see which districts have large, urban bodies, which have a higher proportion of agricultural land versus built up land, and so on and so forth, right? If you go in, you will find these small speckles of red. A question arises, and what are these, right? I mean, are these really built ups or are these errors? Well, for that one could actually, let's say which district are we in? We are in Hardoi. So let's actually go and open, Google Maps and maps.google.com. Okay, I'm going to open Google Maps. Okay, I'm going to now look at the satellite layer and I'm going to say Hardoi, show me Hardoi. Okay, all right, now let's look at the district of Hardoi. Okay, so if we go on to, if we zoom out a little bit, this is a satellite pictures and you can see these little speckles of white in green, right? These little speckles of white. What these speckles are small townships or villages which have built up areas, right? So this sort of also gives you a sense of population pressure. So, if you zoom in to any speckle, what you're going to see is a built up area, right? So there's a little, built up areas with different names. There are these settlements inside, the rural areas. These may be different villages, town centers, and so on and so forth, right? Bigger town centers will have, bigger footprints. So if I go back to my map, that's what little speckles are showing me, right? Little villages or town centers, we are looking at the locations at that fine detail as actual data. What I could also do is, instead of districts, say if I had an interest in, the groundwater data and land use data. So I can go back to my symbology. And I could work with, say, something like proportional symbols. And I did this earlier. I'll just want these from 1 to 40. Okay, 40. Yes, there we go. Fantastic. And I have 5 classes. Now I could, if I wanted, I could actually just say I don't want any fill. I won't want any fill. Okay, no color. Apply. Do I get it? No, I don't get it. So wait. So I am getting no color. Outline color, I want, let's say, blue. I will say apply. Nope. So apply. Okay. Yeah. So I want an outline color, but I do not want a, apply. Okay. I want no color. Apply. Done. Okay. Fantastic. Now, the bigger the circles we saw earlier is the depletion is a a characteristics of a depletion problem. Now, the bigger colors are near this green, right, or they are near the urban built-up. Smaller colors, let's figure out where the smaller circles are in oranges. What are the oranges? Well, they are, let's go back and look at the data. Okay, I know this is built up, Kharif and Rabi. So, Rabi lands have proportionately lower amount of depletion than when lands are double or triple crop. This is a very interesting thing that I've learned from the data, right? So you can sort of, by simple visualization, you can start to make these, connections between land use types and groundwater extraction or groundwater depletion, right? And okay, so of course the next step would be to formally connect them and run regressions based on groundwater levels and how are they dependent on land use types and so on and so forth. Okay, so for that we will, as I said, that type of analysis is more convenient in a statistical software like R. R is also really powerful because it's because of its open source nature. So anybody can download it. It's free of cost, unlike ArcGIS. So we will cover those types of analyses in R. Okay. So with that, we are about done with our session on ArcGIS. Again, we have learned how to set up the software, how to open vector data, raster data, manipulate them, clip them, how to sort of walk between an Excel file and a vector file of attribute table. So we've learned quite a bit tools. I hope they'll be helpful for you. But I want to end by saying that this is just a ramp up. There's an entire toolbox in front of you, right? We saw under geoprocessing. There's all these tools. They can all do very interesting things. So it depends, how far you go in terms of experimenting and spending time. I highly encourage you that you do that. Okay, so thank you very much for your attention. We are done with ArcGIS hands-on, sessions, and next up are sessions on hands-on exercises with R. Okay, thank you.